What if I told you that winter can no longer kill your battery? No range collapse. No frozen charging. Number 40% loss overnight. At 22 degrees Fahrenheit, where most electric vehicles become unreliable, a new battery just kept 99% of its capacity. And here's the part that should make Tesla, Toyota, and every EV giant uncomfortable. It's not a lab prototype anymore. It's entering mass production, and it's happening this March. This isn't a leaked patent. This isn't a concept slide. This isn't a promise for 2035. This is Donut Lab. And they claim they've done what the industry said was a decade away. So today, we're breaking down what Donut Lab actually mass-produced, why to 2F performance changes everything, whether the 99% capacity claim is believable, and how this could quietly reshape the EV and energy industry. Because if this battery is real, the rules just changed. In this video, we'll examine how Donut Lab's solid-state battery moves from hype to reality by entering mass production in March, why its extreme cold weather performance matters more than headline energy density, and whether this technology represents a true turning point toward just the most convincing battery claim we've seen so far. Why cold weather is the real EV killer. Most people think EV batteries fail because of range anxiety. That's not the real problem. The real enemy of batteries is temperature, especially cold. At low temperatures, lithium ions move slower. Electrolytes become resistive. Internal resistance skyrockets. Charging speeds collapse. Degradation accelerates. Tested to 2F30C. Typical lithium-ion batteries lose 30 to 50% capacity. Fast charging can be disabled entirely. Battery management systems throttle output to protect cells. This is why EV adoption struggles in Northern Europe, Canada, Northern U.S. high-altitude regions, industrial cold storage operations. So, when Donut Lab says 99% capacity at 22F, that's not a minor improvement. That's a physics-level disruption. What solid-state actually means, let's clear something up. Solid-state battery is one of the most abused terms in tech. Most companies claiming solid-state are actually using semi-solid electrolytes, gel polymers, hybrid liquid-solid systems. True solid-state means no liquid electrolyte, solid ion conducting material, no leakage, vastly improved thermal stability. Donut Lab claims their battery uses a ceramic-based solid electrolyte, lithium metal, or lithium-rich anodes, a cell architecture optimized for cold ion mobility. Does this matter? Because liquids freeze or thicken. Solids don't if engineered correctly. That's the core reason solid-state batteries can theoretically dominate cold climates. But theory isn't production. Which brings us to the real headline. Mass production, the most dangerous word in batteries. Battery history is littered with broken promises everyone can make one cell in a lab under perfect conditions. Misproduction means repeatability, yield, consistency, cost control, supply chain reliability. When Donut Lab says mass production starts in March, they're implying pilot manufacturing lines are already operational. Quality control metrics are locked. Failure rates are acceptable. Materials sourcing is stable. This is the moment where 90% of battery startups die. Yet Donut Lab claims they've crossed it. Why? Because they didn't design the battery for EVs first. The Donut Lab strategy, most people miss it. Instead of chasing Tesla directly, Donut Lab targeted robotics, industrial machines, military-adjacent cold operations, modular power systems. Shui. Is that smart? Because these sectors pay more per kWh. Cold performance matters more than cost. Safety matters more than energy density. Certification cycles are faster. This allowed Donut Lab to mature the chemistry, validate cold weather reliability, scale slowly without high pressure. By the time EV companies noticed the battery was already real, the 22 degrees Fahrenheit TESTWHY 99% is insane. Let's be brutally honest. 99% capacity retention at 22F sounds impossible. So what could it actually mean? Most likely, capacity measured under controlled discharge, low rate output, not peak acceleration, optimized thermal insulation, smart current management. But even with those caveats, most lithium-ion cells struggle to maintain 70% at that temperature. Solid electrolytes usually suffer from grain boundary resistance, microfractures, Interface degradation. If Donut Labs solve that, they solve the hardest problem in battery science. What they're not saying, every breakthrough hides trade-offs. The unanswered questions. What is the energy density compared to 4680? How fast can it charge at 20 TF? What's the cycle life under real-world stress? What's the cost per kWh today, not in 2030? Silence here doesn't mean deception. It means strategic timing. Battery companies reveal data only when contracts are signed, production is locked. Competition can't react fast enough. Why Tesla should care? Tesla dominates manufacturing scale, cost reduction, software optimization, but Tesla's weakness has always been cold weather efficiency, lithium-ion thermal dependence. If Donut Labs battery proves reliable, scalable, even moderately affordable, then Tesla faces a decision: license partner or accelerate internal solid-state timelines. And Tesla is not the only one watching. The global ripple effect of cold-proof battery impacts EV adoption in extreme climates, Arctic logistics, renewable energy storage, military operations, space-adjacent systems. It removes one of the last excuses against electrification. No warming delays, no heated garages, no winter penalties. Just power. Is this the battery revolution? Probably not overnight, but revolutions don't announce themselves loudly. They start in factories and contracts and quiet shipments. March production matters more than any press release. For decades, solid-state batteries were 5 years away. Now one company says, we're building them this month. If Donut Labs claims hold up, if the 22F performance scales, if mass production survives real-world stress, then history may remember this moment as the end of Winter Limited. Batteries. Not with a bang, but with a donut-shaped hole punched straight through the old limits of energy storage.